Hello everyone, welcome to my channel. Now in this video we are going to solve a few questions from the chapter Work Energy Power which have come in NEET examination. So this is from NEET 2018. A body initially at rest and sliding down a frictionless track from a height h. So this is the body, this is a frictionless track, this is height h, just completes a vertical circle of diameter AB equal to d. So this body comes like this and then completes a vertical circle. The diameter is d. The height h is equal to. These are the available options. Now using a principle of conservation of energy between this point and this point, the highest point and the lowest point. Okay, so at highest point the energy is in the form of potential energy. So this height is h, so potential energy at this point is mgh. Okay, now initially the block is at rest, so the kinetic energy is 0. So this is the total energy at this particular point. Now when it slides down from this point to this point, this is the lowest point and height is measured from this. So here the height is 0. So at this location the potential energy is 0 and kinetic energy is half mv square. Okay, so this is the total energy at A and this is the total energy at height h. So by applying principle of conservation of energy, we can equate these two energies. So this is mgh is equal to half mv square. Okay, so this cancels out, so v square is equal to 2gh, or v is equal to square root of 2gh. Okay, now this particle or this body, it is able to complete the vertical circle. So the condition for a body to complete the vertical circle is the velocity at this point, it must be greater than equal to square root of 5g r, where r is the radius. So that means this velocity should be greater than equal to 5g r. So that is 2gh should be greater than equal to square root of 5g r. Okay, so this gives h is equal to 5r by 2. Okay, but r is the radius. Here it is, d is the diameter. So twice r is equal to d. So that is r is equal to d by 2. So this is 5 d by 2 divided by 2, so that is equal to 5d by 4. So of the given options, option 4 is the correct answer. This is from NEET 2017 problem. Consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second. Take g is equal to 10 meter per second square. The work done by the gravitation force and the resistive force of air. So two things we have to find, and these are the available options. Okay, now looking into the options, see, work done by resistive force. Now when the water drop, it is coming downward, the resistive force will act in the upward direction. Okay, so it is undergoing displacement in this direction, force is acting in this direction. So this work done by the resistive force, it has to be a negative quantity. Okay, now out of the given options, option 1 and option 3, here we see that resistive force, it can be minus 8.25, it can be minus 8.75, because these are only negative options. Okay, this is also negative, but see, this work done by gravitational force, it is also given negative. So for gravitational force, this is the water drop gravitational force, it is acting in the downward direction. Displacement is also taking place in the downward direction. So for this work done by gravitational force, it has to be a positive quantity. So this answer is not possible. Okay, so of the given options, only these two options are looking to be a possible options. Okay, now let us see how to proceed further. Now work done by gravitational force, it is mgh. Okay, now mass is, so this is mgh, mass is 1 gram, so that is 10 power minus 3 kg, g is 10, height is 1 kilometer, so that is 10 power 3 meter, so this is equal to 10 joule. Okay, so out of these two, this is 10 joule, so option 3 is the correct answer. Now let us also calculate, though we know that this is the correct answer, let us also calculate the work done by resistive force. Now while falling down, it is having kinetic energy, and that kinetic energy is going to be expended into two forms. So that is, this kinetic energy will be spent as work done by gravitational force and also work done against the resistive force of air. So half mv square is equal to work done by gravitational force plus work done by resistive force. Okay, now half mv square, mass is 1 gram, so this is 10 power minus 3 v square, speed is 50 meter per second, so 50 square is equal to work done by gravitational force is 10 plus WR. So this is 1.25 is equal to 10 plus WR. So this gives WR is equal to 1.25 minus 10, so minus 8.75 joule. So this is the correct answer. So this is again from NEET 2017, problem related to spring. Spring of force constant K is cut into lengths of ratio 1:2:3. They are connected in series and the new force constant is K dash. Then they are connected in parallel and the force constant is K double dash. The ratio K dash to K double dash is. So these are the given options. Okay. Now for a spring, the product of K into L, spring constant into length, this is always a constant. Okay. This is the main concept behind this question. So now ratio of length L1 is to L2 is to L3, it is 1:2:3. So that means the ratio of the spring constant K1 is to K2 is to K3 is equal to 1/1 is to 1/2 is to 1/3. Okay. Now K dash, it is given that K dash is the new force constant when they are connected in series. Now equivalent force constant in series, it is 1 by K dash, it is equal to 1 by K1 plus 1 by K2 plus 1 by K3. Okay, so that is equal to 1 plus 2 plus 3 is equal to 6. Okay, now similarly when they are connected in parallel, K double dash will be equal to 1 plus 1 by 2 plus 1 by 3. Okay, so this is how much? 6, 11 by 6. Okay, now remember this K dash, it is 1 by K dash is 6, so K dash is 1 by 6. Now the question asks is ratio of K dash to K double dash. So K dash by K double dash is equal to 1 by 6 divided by 11 by 6. That is equal to 1:11. So of the given options, option 2 is the correct answer. Now this question is from NEET 2016 phase 2. Two identical balls A and B having velocities 0.5 meter per second and minus 0.3 meter per second respectively collide elastically in one dimension. Okay, so they have same mass, they are identical, so they have same mass. They are moving in opposite direction. A is moving with velocity 0.5 meter per second. B is moving with velocity minus 0.3 meter per second. Minus denotes it is moving in the opposite direction. And they undergo elastic collision. The velocities of B and A. Okay. In the question they have given the velocity of A and B. This is A and this is B. And they have asked the velocities of B and A after collision respectively. Okay. Now the thing is, see, if the balls are identical and they are undergoing collisions in one dimensions, they will interchange their velocities. Okay, they will interchange their velocities. So B will acquire a velocity of 0.5 meter per second and A will acquire a velocity of minus 0.3 meter per second. So of the given options, option 3 is the correct answer. This is a direct question. So this is from NEET 2016 phase 2. A particle moves from point minus twice I cap plus 5j cap to 4j cap plus 3k cap. When a force of 4i cap plus 3j cap Newton is applied, how much work has been done by the force? Okay. Now see, this is the initial position and this is the final position. So the displacement S, it is always final position minus initial position. This is RF, this is RF and this is RI. So this is 4j cap plus 3k cap minus this quantity. So this will become plus twice I cap minus 5j cap. Okay, so this becomes twice I cap minus j cap plus 3k cap. Okay, so this is the displacement. What is the force? 4i cap plus 3j cap. So work done W, it is dot product of force and displacement. So F dot S. So this is 4i cap plus 3j cap dot twice I cap minus j cap plus 3 k cap. So this is 4 to the 8 minus 3, so this is 0, so that is equal to 5 joule. So 5 joule is the final answer. So option 4 is the correct answer. So this is from NEET 2016 phase 1. A particle of mass 10 gram moves along a circle of radius 6.4 centimeter with a constant tangential acceleration. What is the magnitude of this acceleration if kinetic energy of the particle becomes equal to 8 into 10 power minus 4 joule by the end of second revolution after beginning the motion? Okay. So now in this question we have to use work energy theorem. Work energy theorem. That is, work done is equal to change in kinetic energy. Work done is equal to change in kinetic energy. So here work done is force into displacement. Now force is mass into acceleration, tangential acceleration into displacement is equal to the kinetic energy. Okay. After beginning the motion, so initial energy is 0. So final energy is half mv square. So half mv square minus 0 is half mv square. Okay. Now what is S here? Second revolution. See, by the end of second revolution, so S will be 2 times twice pi r. Okay. Radius is 6.4 centimeter. Okay. So mass is 10 gram. So this is 10 into 10 power minus 3. 80 tangential acceleration multiplied by this quantity 4 pi, radius is 6.4 centimeters, so 6.4 into 10 power minus 2 is equal to half mv square. The kinetic energy is given 8 into 10 power minus 4. Okay. Now on solving this you will get 0.1 meter per second square. So option 2 is the correct answer. Now this is from AIPMT 2015. See, prior to 2016 the NEET exam was called AIPMT All India Pre-Medical Test. So this is from AIPMT 2015. A block of mass 10 kg moving in x direction with a constant speed of 10 meter per second is subjected to a retarding force of F equal to 0.1 x joule per meter during its travel from x equal to 20 meter to x equal to 30 meter. Its final kinetic energy will be. Okay. So here the final kinetic energy is asked. Okay. Now work is done by retarding force. So here work done will be minus f of dx. You have to integrate it from x equal to 20 to x equal to 30. Okay. Now why work done is negative here? Because the force is retarding. That is, if the object it is moving in this direction, the force retarding force is acting in this direction. So this is the direction of displacement and this is the direction of force. Okay. Hence here work done is negative. So this is the work done. So that is minus x equal to 20 to x equal to 30. F is 0.1 x dx. Okay. So this is minus 0.1. Integration of x dx is x square by 2. Limit is x equal to 20 to x equal to 30. Okay. So this is minus 0.1, 30 square by 2 minus 20 square by 2. Okay. So this is minus 0.1 into 500 divided by 2. So that is equal to minus 25 joule. So work done by the retarding force is minus 25 joule. Now work energy theorem, it says that work done is equal to change in kinetic energy. That is, work done is equal to final kinetic energy minus initial kinetic energy. Okay. Now work done is minus 25 joule. So minus 25 joule. We have to find the final kinetic energy. Okay. What is the initial kinetic energy? It is moving with the speed of 10 meter per second. Its mass is 10 kg. So minus half into 10 into 10 square. So this is this becomes minus 25 is equal to kf final kinetic energy minus 500. So kf is equal to, this comes over here. So this is 475 joule. Okay, so of the given options, options 4 is the correct answer. So this is another spring based question in the year EAPMT 2015. Two similar springs P and Q have spring constant Kp and Kq such that Kp is greater than Kq. Okay, so first information is Kp is greater than Kq. This is given. Okay, they are stretched first by same amount case A and then by same force, that is case B. The work done by the springs Wp and Wq are related as in case A and case B respectively. These are the given options. Okay, now work done in the spring is stored in the spring as a potential energy. Now potential energy of the spring can be written into three forms: half kx square, potential energy of the spring is half kx square, or potential energy of the spring as half fx, or potential energy of the spring as f square by twice k. Okay, these are the three ways of writing the expression for potential energy of the spring. Okay, so now first case, they are stretched by the same amount. Okay, now when they are stretched by the same amount, that is x is same for them. Okay, now if we use this relation, x is same for them, so now Kp is greater than Kq, so this quantity for P is greater than the quantity for Q, so that means the potential energy stored in P will be greater than that of Q. So this implies Wp is greater than Wq. Okay, so this is the first part. Okay, now how about the second part? Second part, then by the same force. Okay, when they are stretched by the same force. Now same force means we'll use this relation. Now if you see this relation, for both the springs F is same, but K for P, spring P is greater than that of Q. So in this case US is inversely proportional to K. So this implies potential energy or for stored in Q will be greater than that in P, or work done in Q will be greater than that in P. Okay, so if you see option 2, Wp greater than Wq for first case, Wq greater than Wp, that is the second case. So option 2 is the correct answer.